I'm Kirtana from group number 329. Today I'm here to present the milestone 2 of our project Code Genie. Code Genie is a VS Code extension which helps in code generation, explanation, and debugging. So the major things which I learned from this project are VS Code API and WebView communication, wherein I explored how the backend gives the response and how we display it in the web panel. Next, the Fast API. We preferred Fast API as it is lightweight, has high performance, and is more compatible for AI models. Next comes LLM CPU inference. Initially, it was very difficult for us to run the 1.3 billion parameter DeepSeek model in our local CPU, but with the help of Olama, we could catch up. But later on, when we shifted from Olama to manually downloading it, we made some changes like D-type float 32 to float 16. And also, next comes the latency management, where we streamlined the prompt and decreased the token size to reduce the load on the RAM. And prompt engineering also we learned as for debugging, explaining the prompt engineering made the work more effective. Like for debugging, we wrote your debug analysis and you can do this and that. So it was easy for us. The tech stack, the main tech stacks which we are using are Python and TypeScript for programming languages. Python is for backend API, Fast API. And as told earlier, we used a Fast API as it is lightweight and gives a high performance when compared to other. And it also supports asynchronous server gateway interface. Next comes the AI model and libraries. We use DeepSeek Coder as it is open source and it is especially trained for coding languages. It allows multiple languages. And for front end, for WebView panel, we use JavaScript, HTML, and CSS. So initially, we were thinking to use Olama for running our DeepSeek model, but later we shifted by downloading the model manually the H5 files. So this is the final architect user. So now let's go through the working model or demo. So this is our main project. The source folder contains the extension.ts and server folder contains server.py. Firstly, we are importing all the VS Code API functions from VS Code and Axios for HTTP requests. Next, the VS Code window.onDid change active text editor. Whenever we change the editor, it gets called. And last generated, we have taken a variable last generated code. And we are also storing saved editor. For language detection, we are storing it in language ID. Here we get the web view panel. So panel.webview onDid receive command. It enters this. So whenever the user clicks on fetch suggestion, then the content from the active editor, active or the save editor is collected and it is sent to the backend. So the prompt which we gave is the language ID, that is either JavaScript or C# or anything. Then the context and provide only the correct code inside the triple brackets. This is the prompt. Then here the hash generate endpoint which is present in our server. This is called. The process is the AI model gives the answer in a JSON format. Then we extracted the code inside the backticks. Next, this one, the last generated code is present in this, stored in this last generated code variable. Then this dot post message, it displays the code suggestion in the panel and then it indeed we can insert it. Similarly, debug, the code snippet is selected which we want to debug. It is sent to the backend. This is the debug prompt. Here it is sent to the backend. The maximum tokens is 500. We get the response from the backend, which is then shown in the panel. So similarly, for explain, we do the same thing. Lastly, insert. For inserting from the web view panel, we insert it to the saved editor. For that, we use edit builder, editbuilder.insert. Now, this style URI and script URI refers to the main.js and styleman.css in the media folder. This is basically the front end which we have. WebView.html, this is the overall front end of the web panel. The CSS styling of this is present in this folder, and main.js, the buttons functions is present in this file. So we have 4 buttons, mainly suggestion button, explanation button, insertion button, and debugging. So now let's go to the server.py. We are importing fast API and importing auto model for casual large models, large language models, and auto tokenizer from transformers using Hugging Face. And as told earlier, we have downloaded the model locally, so it is present at this location. As the device is since now we are using CPU, we can later change it to GPU. So tokenizer, the model is loaded with float 16. The default one is float 32, and the device is CPU. So this is the endpoint of the endpoint, which is hash generate. It is used to generate code completion based on the input prompt. Whenever the prompt is given, it comes to this endpoint where the AI model sends the output in the form of JSON. Next, max tokens is the number of maximum tokens which we can give. Do sample is equals to false means the most likely token is given in the next step instead of giving randomly. And years token tells the last line, like when to stop the code generation. So our server runs at this port. So now let's go through the demo of this once. Let's run the server. Similarly, we will compile this extension.ts. So extension is compiled. Now we have to open the VS Code developer window by pressing function F5. You would be getting a window like this. Now we will call our extension. For that, we will press Control Shift P and enter the generate code with Code Genie Sam, which is the name of my extension. So let's block the prompt. We'll choose an action like get suggestion. It would give us the appropriate code. Click on execute. Now let's wait for 2 to 5 minutes. So after 2 to 5 minutes, you will be getting the AI generated code. Now to insert it back into the active editor, click on insert and execute. You can see the output. Let's check out explain button. Click on explain code. So after 2 minutes, you can see that this is the explanation of the given code. Similarly, if we forget any semicolon or something, we can go with the debug option. Let's block the code. Click on debug code and execute. Let's wait for 2 minutes. So this is the debug code. Milestone one goals versus the achievements. I think we have succeeded in achieving them. As promised, we promised about VS Code integration with LLM. So without using Olama and Hugging Face online, we downloaded the model and completed it. Real-time code suggestions, it is doing real-time code suggestion. It is generating the code, debugging it, inserting and explaining. Next comes the local model deployment. We are locally running it on the CPU or the GPU. No online is required. And we have achieved the suggest, explain, and the debug features. Fast API server with DeepSeek coder, and it works fully offline on CPU or GPU. Internet is not required at all. Next comes the challenges which we faced. Running a large language model on CPU was very difficult. So initially we tried using the Olama during the starting days, and for this we also had to research a lot. And then next we replaced it by Hugging Face API, and further we replaced that too with by downloading the H5 files and running locally. The model deployment is without Hugging Face and Olama. It is completely locally on our CPU or GPU. And also we faced problem while connecting the fast API and the web view. The response had to be shown on the web view, and then inserting into the active editor was also a problem. Next, let's know why DeepSeek coder means. As our problem statements contains DeepSeek coder, we chose that. And also it is an open source model. We can experiment with it a lot. We can fine tune it, and the model sizes are various like 1.3, 6.7. For our CPU, we are using 1.3, and for GPU, we are using 6.7. So it is much more, it has much flexible model sizes. Other models which we reviewed was Code Llama. It was nice, but it couldn't run it on our CPU. Star Coder was also a good one, but a very complex one to run on CPU. Mistral, which we tried, but it was for normal NLP, not for code one. Deployment goals are we are running it locally on CPU or GPU. No cloud services required now. No Llama or Hugging Face is required. It is very secure and no internet dependency. And the model and interface scripts run entirely on the user's machine. Lastly, the future plans which we would like to implement is we would improve our UI better, and security and privacy settings, allow users to control what data is stored or shared. so that it maintains the security and privacy and nothing, no information is sent to the model. We would also like to add a toggle button for offline mode, so that more private information won't leak to the AI model. And we would also like to implement open source project so that other users can, developers can also contribute to our project. And last, thank you.